Imagine gazing upon a night sky ablaze with vibrant hues of green, blue, and red. These dancing lights weave and swirl, captivating the observer with their ethereal beauty. This is the Aurora Borealis, a breathtaking spectacle that has mesmerized humanity for millennia. Known as the Northern Lights, this celestial display transforms the night sky into a canvas of otherworldly wonder. Ancient cultures wove tales of gods and spirits, attributing the lights to supernatural forces. Some believed them to be messages from the heavens, while others saw them as harbingers of great change. Today, we understand the science behind this captivating phenomenon. The Aurora Borealis remains a testament to the power and beauty of the natural world, a humbling reminder of our place within the vast cosmos. The sun, our very own star, is a giant ball of burning gas. It constantly releases a stream of charged particles called the solar wind. When this solar wind reaches Earth, it encounters our planet's magnetic field, a protective shield that surrounds us. Earth's magnetic field acts like a giant magnet, deflecting most of the sun's charged particles. However, some of these particles are captured by the magnetic field lines and guided towards the poles. These particles then collide with atoms and molecules in Earth's upper atmosphere, primarily oxygen and nitrogen. These collisions excite the atoms, causing them to release energy in the form of light. Green, the most common color, is produced by excited oxygen molecules. Blue and purple hues are generated by excited nitrogen molecules. The Aurora Borealis has captivated the human imagination for centuries, leaving its mark on the folklore, mythology, and art of cultures across the globe. For the Inuit people of the Arctic, the Northern Lights were believed to be the spirits of their ancestors, dancing and playing in the night sky. In Norse mythology, the aurora was said to be a bridge, Bifrost, connecting the realm of the gods to the human world. The Northern Lights have inspired countless works of art, from paintings and poems to music and dance. They have also sparked scientific curiosity, leading to a deeper understanding of our planet and its place in the cosmos. The Aurora Borealis is more than just a scientific phenomenon, it is a cultural touchstone, a symbol of the beauty and mystery that surrounds us. The Aurora Borealis, a breathtaking display of light in the night sky, is a captivating phenomenon that has fascinated humankind for centuries. The answer lies in the interaction between the Sun, our nearest star, and Earth's magnetic field. The Sun, a giant ball of hot gas, constantly emits a stream of charged particles known as the solar wind. As this solar wind approaches Earth, it encounters our planet's magnetic field, a protective shield that surrounds us. Earth's magnetic field acts like a giant bar magnet, with magnetic field lines extending from the North Pole to the South Pole. However, some of these particles manage to penetrate the magnetic shield, especially near the poles, where the field lines are weaker. When these charged particles from the Sun collide with atoms and molecules in Earth's upper atmosphere, they transfer their energy, causing the atoms to become excited. In the case of the aurora, the excited atoms release their excess energy in the form of light, creating the mesmerizing auroral displays. The color of the aurora depends on the type of atom or molecule that is excited. The most common color, green, is produced by excited oxygen atoms at lower altitudes around 60 miles above Earth's surface. Red auroras, which are rarer, are also produced by oxygen, but at higher altitudes, where the atmosphere is less dense. Blue and purple auroras are generated by excited nitrogen molecules. These factors create the dynamic and ever-changing patterns of the Aurora Borealis, making each display unique. The intensity of the Aurora Borealis is directly related to the strength of the solar wind. During periods of high solar activity, such as solar flares or coronal mass ejections, the Sun releases massive bursts of energy and charged particles. These events can trigger intense geomagnetic storms on Earth, resulting in particularly vibrant and widespread auroral displays. The shape and movement of the aurora are influenced by Earth's magnetic field. As charged particles from the solar wind are guided along the magnetic field lines towards the poles, they spiral downwards into the atmosphere. The Aurora Borealis is most commonly seen in a band around the magnetic North Pole, known as the Auroral Oval. During intense geomagnetic storms, the Auroral Oval can expand southward, making the northern lights visible at lower latitudes. The scientific study of the Aurora Borealis has revealed a fascinating interplay of solar physics, atmospheric science, and electromagnetism. Scientists use a variety of instruments, including ground-based observatories, satellites, and sounding rockets, to study the aurora and its effects on Earth's atmosphere. Intense geomagnetic storms, while creating spectacular auroral displays, can also disrupt radio communications, GPS systems, and power grids. Understanding the science behind the aurora is crucial for mitigating the potential impacts of space weather on our technology-dependent society. Ongoing research into the Aurora Borealis continues to unveil new insights into the complex relationship between the Sun and Earth. Chasing the Northern Lights, a guide to prime viewing locations. For those seeking the ethereal beauty of the Aurora Borealis, a journey to high-latitude destinations is a must. The Northern Lights, as their name suggests, grace the skies of the Northern Hemisphere, primarily within a band known as the Auroral Oval. Among the top contenders for aurora viewing are the Nordic countries. Norway, with its stunning fjords and picturesque villages, offers a magical backdrop for witnessing the celestial spectacle. Tromsø, often dubbed the gateway to the Arctic, is a popular starting point for aurora tours. Finland, with its vast forests and pristine lakes, is another prime location for aurora chasers. The Finnish Lapland, a winter wonderland, offers a serene escape for experiencing the northern lights. Inari, home to the Sami people, is a cultural hub where visitors can learn about the indigenous folklore surrounding the aurora. The Auroral Oval, where the lights dance most vividly. The Auroral Oval, a ring-shaped region centered around the magnetic North Pole, marks the zone where auroral activity is most frequent and intense. During periods of high solar activity, the oval can expand southward, bringing the northern lights to lower latitudes. Within the Auroral Oval, certain locations have gained a reputation as aurora hotspots. Fairbanks, Alaska, located directly beneath the Auroral Oval, boasts a high probability of aurora sightings during the winter months. Yellowknife, Canada, situated on the shores of Great Slave Lake, is another prime spot for aurora viewing, known for its clear, dark skies. Iceland, a land of fire and ice, offers a unique perspective on the Aurora Borealis. Timing is everything, predicting auroral activity. While the Aurora Borealis is a year-round phenomenon, the best time to witness this celestial display is during the winter months, from September to April. During these months, the nights are long and dark, providing ample opportunity to observe the aurora. Predicting auroral activity with pinpoint accuracy is challenging, as it is influenced by the unpredictable nature of the solar wind. However, scientists have developed tools and models to forecast auroral activity based on solar observations and geomagnetic indices. Websites and apps such as spaceweather.com and Aurora Forecast provide real-time updates and predictions to aid aurora hunters. Clear, dark skies are essential for optimal aurora viewing, therefore, it is advisable to venture away from urban centers and seek out remote locations with minimal light interference. Essential tips for aurora hunters. Gear up for an unforgettable experience. Embarking on an aurora hunting adventure requires preparation and the right gear to ensure a comfortable and rewarding experience. Dressing warmly is paramount, as temperatures in high-latitude regions can plummet during the winter months. Layering clothing, including thermal underwear, fleece jackets and waterproof outer layers, is essential for staying warm and dry. A sturdy tripod is a must-have for photographers hoping to capture the beauty of the Aurora Borealis. A wide-angle lens with a fast aperture, f2.8 or lower, is ideal for capturing the expansive auroral displays. Bringing along a headlamp or flashlight with a red light setting is recommended for navigating in the dark while preserving night vision. Extra batteries are always a good idea, as cold temperatures can drain battery life quickly. Legends in the sky, ancient myths and folklore of the aurora. For millennia, the Aurora Borealis has painted its ethereal glow across the night sky, captivating those fortunate enough to witness its celestial dance. Long before the advent of modern science, cultures around the world wove intricate myths and legends to explain this awe-inspiring phenomenon. In Norse mythology, the Aurora Borealis was believed to be the shimmering reflection of the Valkyries, female figures who rode across the sky, gathering fallen warriors and escorting them to Valhalla. The Inuit people of the Arctic had their own captivating tales about the northern lights. They believed that the aurora was the spirits of their ancestors, playing a celestial game of soccer with a walrus skull. The flickering, dancing movements of the lights were seen as the spirits moving across the sky, their laughter echoing in the rustling of the wind. Divine bridges and celestial serpents, cultural interpretations across the world. The Aurora Borealis, visible across a wide swathe of the Northern Hemisphere, has inspired a diverse array of cultural interpretations. In Finnish mythology, the lights were known as revontule, meaning foxfires. According to legend, an Arctic fox running across the snow would sweep its tail across the sky, creating sparks that ignited the aurora. In Chinese folklore, the Aurora Borealis was often associated with dragons, mythical creatures believed to control celestial elements. The lights were seen as the fiery breath of celestial dragons, illuminating the night sky with their awe-inspiring power. The Maori people of New Zealand, despite their geographical distance from the auroral displays, had their own unique interpretation of the southern lights, known as Aurora Australis. The ethereal beauty and captivating mystery of the Aurora Borealis have captivated artists, writers and musicians for centuries, inspiring countless works of art, literature and music. From ancient cave paintings to modern-day photography, the Northern Lights have served as a muse, capturing the human imagination and pushing the boundaries of creative expression. One of the earliest known depictions of the Aurora Borealis can be found in a cave in France, dating back over 30,000 years. In literature, the Northern Lights have been featured in works ranging from Shakespearean plays to modern novels. More recently, authors such as Philip Pullman in his Dark Materials trilogy have incorporated the aurora into their narratives, using its otherworldly beauty to evoke a sense of wonder and mystery. While ancient cultures wove myths and legends to explain the Aurora Borealis, the scientific quest to understand this celestial phenomenon began in earnest during the 17th century. Early scientists, armed with rudimentary telescopes and a thirst for knowledge, began to study the aurora systematically, recording its movements, colors and patterns. One of the pioneers of auroral research was the Norwegian scientist Christian Birkeland. In the late 19th and early 20th centuries, Birkeland conducted a series of experiments using a terrella, a magnetized sphere representing Earth, to simulate the interaction between the solar wind and Earth's magnetic field. His work laid the foundation for our modern understanding of the aurora. Today, scientists continue to study the Aurora Borealis using sophisticated instruments, including ground-based observatories, satellites, and sounding rockets. These studies have revealed a complex interplay of solar physics, atmospheric science, and electromagnetism, providing insights into the dynamics of our planet's upper atmosphere and its interaction with the Sun. Today, the quest to understand the Aurora Borealis reaches new heights, empowered by cutting-edge technology that allows us to study this celestial ballet with unprecedented detail. No longer confined to ground-based observations, scientists now have a fleet of spacecraft and sophisticated instruments at their disposal, revealing the aurora's secrets from the unique vantage point of space. Satellites orbiting high above Earth's atmosphere provide a global perspective on auroral activity. NASA's Themis mission, consisting of 5 identical spacecraft, has revolutionized our understanding of how auroras are generated. These spaceborne sentinels capture images of the aurora from multiple angles simultaneously, allowing scientists to create 3-dimensional maps of these dynamic displays. Ground-based instruments complement these space-based observations, providing detailed measurements of the aurora's electromagnetic signatures and the particles that create them. Advanced radar systems, such as the IISCAT, European Incoherent Scatter Scientific Association radar, bounce radio waves off the auroral curtain, allowing scientists to probe the density, temperature, and movement of the charged particles within. Section 2, Beyond the Visible Spectrum, exploring the aurora's hidden dimensions. The Aurora Borealis is far more than meets the eye. It emits radiation across the electromagnetic spectrum, from radio waves to X-rays. UV cameras reveal intricate details of auroral structures. X-ray observations show high-energy X-rays from solar wind collisions. The sound of silence, debunking the myth of auroral acoustics. Tales of strange sounds with the Aurora Borealis have persisted for centuries. However, scientific evidence remains elusive. Sound waves need a medium to travel, unlike light waves. The thin upper atmosphere makes sound propagation unlikely. Auroras occur hundreds of miles above, making sound travel difficult. Section 4, Space Weather. Watchdogs predicting auroral activity in the 21st century. As our reliance on technology grows, so too does our vulnerability to the whims of space weather. Intense geomagnetic storms triggered by solar flares and coronal mass ejections can disrupt radio communications, GPS systems, and power grids, potentially causing widespread chaos and economic damage. Predicting auroral activity, a visible manifestation of space weather, has become increasingly important in mitigating these risks. Scientists now use a combination of ground-based and space-based observations, coupled with sophisticated computer models, to forecast auroral activity and provide early warnings of potential space weather threats. The National Oceanic and Atmospheric Administration, or NOAA Space Weather Prediction Center, known as the SWPC, is a leading source of space weather information and forecasts. The SWPC issues regular alerts, warnings, and advisories on geomagnetic storms, solar radiation storms, and radio blackouts, providing crucial information to industries and organizations impacted by space weather. The Aurora Borealis, a celestial ballet of light and color, has captivated humankind for millennia. From ancient myths to modern science, we seek to understand this awe-inspiring phenomenon. It reveals the intricate connection between our planet and the universe. The Aurora Borealis showcases the power of the sun and Earth's protective magnetic field, a spectacle of nature's artistry, painting an ethereal masterpiece. We are reminded of our place within the grand tapestry of the universe. The allure of the Aurora Borealis transcends time and culture. For centuries, people have traveled to witness this celestial spectacle firsthand. The pursuit of the aurora has become a pilgrimage of discovery and connection. Photographers and artists strive to capture its ephemeral beauty. Witnessing the aurora leaves an indelible mark, a memory etched forever. It is a reminder of the magic in the world if we know where to look. The study of the Aurora Borealis has opened a window into the vast workings of the universe. From understanding the sun's atmosphere to Earth's magnetic field, auroral research pushes scientific boundaries. The universe is a place of infinite wonder, filled with mysteries yet to be unraveled. The Aurora Borealis serves as a reminder that the pursuit of knowledge is an ongoing journey. The Aurora Borealis, a celestial guardian of the northern skies, continues to inspire wonder and awe in all who witness its ethereal dance. As we strive to protect our planet and preserve its natural wonders for future generations, the aurora serves as a poignant reminder of the interconnectedness of all things and the importance of safeguarding the delicate balance of our world. By reducing our impact on the environment, promoting sustainable practices and supporting scientific research, we can help ensure that the Aurora Borealis continues to grace our skies for centuries to come. Let us be inspired by its beauty, guided by its wisdom, and dedicated to preserving the wonders of our planet for generations to come. The Aurora Borealis is a gift, a celestial treasure that reminds us of the extraordinary beauty and wonder that surrounds us. May its ethereal glow forever illuminate our nights, inspire our dreams, and guide us towards a brighter future.